Today's lesson is 3-4, exponential and logarithmic equations. We're going to use one of three methods to solve these today. We are either going to use the one-to-one property, and that should have an E right there, or we will start with exponents and turn it into logs, or we will start with logs and turn it into exponents. So one of three methods: one-to-one, exponents to logs, or logs to exponents. On our first 6 examples, the directions say solve. I'm going to add something to this. We are just going to call these simple equations, because when you start doing your homework or your assignment, in the first section, they may not call them simple equations, but what you're going to do here is you are going to simplify. You're going to simplify these, but you're not going to have any decimal answers. Okay, no decimal answers, no decimals. I should separate that a little bit there. No decimals. Okay, on numbers 4 through 6 for our examples. And so you'll find that when you start working the ones in the book, there'll be some that you simplify as much as you can, but no decimals. So let's simplify this as far as we can. 2 to the x power equals 512. Well, we have two options to solve this one. We can either rewrite using the one-to-one property, or after we do that, I'll approach this a different way. So I could say 2 to the x power equals, I could figure out if 512 would be 2 to some power, and that would just be kind of playing around with some exponents and try to figure out, is there an exponent of 2 that equals 512? And if you play around with some exponents, you would discover that 2 to the 9th power is 512, and therefore you can see that the exponents would need to be the same, so x equals 9. But that would be just kind of playing around with some exponents to try to figure out if 2 has an exponent that equals 512. So that's one way. Another way you could find this is you could take this out of exponents, because this is an exponential equation, and you could change this to a logarithmic equation. So I'm going to just say change to logs. So let's use our little left, right, left technique, and this would be log base 2 of 512 equals x, and then we can use our change of base formula in your calculator, and you can just calculate that. Log 512 divided by log 2 in your calculator, and you would find that x equals 9. So two different approaches to come up with the same answer. I'm not going to pull my calculator up because this is a long lesson and I want to save time, but remember that that would be log 512 divided by log 2 in your calculator. So moving on to number 2. ln, which means natural log of 5 minus natural log of x. Let's keep my colors here the same. Let's rewrite using the one-to-one property. So I need to separate these and get 1 on each side of the equal sign. So I'm going to have natural log of 5 equals natural log of x. So once I get this to where I have natural log once on the left and natural log once on the right, I can cancel out the natural logs, and then I just have 5 equals x, and there's your solution. Now I know I haven't had to deal with this no decimals yet, but this is coming up here in just a minute. So far we've had nice whole numbers. Alright, number 3. 1/5 to the x power equals 125. We can use this as the one-to-one property also. Rewrite as one-to-one. Sorry, my pen's going crazy here. 1-to-1. Now, this is going to take some little knowledge of negative exponents. So you have to understand that 1/5 to the x power is the same thing as 5 to the negative x power. You have to understand that those mean the same thing. So 5 to the negative x equals 125. So could you rewrite 125 as 5 to some power? We'll come down here. 5 to the negative x equals 125 is also 5 to an exponent. That would be 5 to the third. So now I have the same bases. If I can get it to where I have the same bases, then I could look at my exponents. That means my exponents have to be the same. So if my exponents have to be the same, then negative x equals 3, so x equals negative 3. And there is number 3. When we look at number 4 starts out as an exponential equation. It doesn't look like there's any one-to-one property to help us there, but what we can do is we can change this to logs by doing our left, right, left. So I would have log base e of 13 equals x. And we talked what log base e represents. Remember, that means natural log of 13 equals x. Now this goes back to what I talked about over here about no decimals. Okay, just simplify, no decimals. If you were to type natural log of 13 in your calculator, you would get a decimal, and we don't want to do that yet. We will here in a few minutes, but right now we just want to simplify as far as we can. We're going to leave it there for now, but here and coming up in a few minutes we will go ahead and calculate that a little further. But that is simplified as far as we can go for now without getting a decimal answer. So we'll stop there for now. Okay, number 5. Natural log of x equals negative 8. Well, let's see. Natural log, ln, stands for log base e. So I'm going to convert that to log base e of x equals negative 8. See if that may help you out a little bit. So if I take this out of a logarithmic equation and I change it back to exponents, let's see if I change this to exponents, if that helps any. So let's go left, right, left. See what happens. E to the negative 8 equals x. Now think about what happens if you calculate e to the negative 8. If you calculate that, are you going to get a nice number, or are you going to get a decimal? You're going to get a decimal, and we're not going to do that just yet, so we will leave it there for now. We'll calculate it here once we get past example 6. One more in this section. Log of x equals negative 2. If there is no base right there, remember that it is an understood 10. Not much you can do there with the form that it's in, so we are going to change this to exponents also, or abbreviate there. So we're going to go left, right, left. 10 to the negative 2 equals x. Now I know I left e to the negative 8 as a negative exponent, but we can simplify this a little bit more. 10 to the negative 2 means 1 over, pen's going nuts again, sorry about that, 1 over 10 to the positive 2, which means 1 over 100. So 1 over 100 is number 6. Now with this section, from here on out, we are going to solve, and we will approximate to 3 decimal places if necessary. So we will calculate these as far out as we can using the calculator, estimating, rounding when appropriate. So for number 7, if you'll look at the way this is set up, we have e to an exponent equals e to another exponent. This is ready to go with our one-to-one property. So I can basically ignore the e's and I can set my exponents equal to each other. Now all I need to do is solve that. That's just a simple quadratic equation I need to solve. I need to get everything on one side of the equal sign, making sure that your x squared is positive. Go from there, just factor x plus 2 times x plus 3, solve for 0, and you're going to get negative 2 and negative 3. On number 8, you will begin solving this one just like you would a regular equation. Your goal is to try to get the x by itself. So the 3 is connected with the x because the 3 is a base. So let's get rid of the 4. This is multiplied. So to undo multiplication, you divide. So I'm going to write over here what we're doing. We are going to divide. So to divide by 4, or divide by 4, so 3 to the x power equals 16. So at that point, you're pretty much done. You've pretty much done as far as you can with it in that form. So what we're going to do now is we're going to change to logs. So go left, right, left. Log base 3 of 16 equals x. Now we can calculate this with the change of base formula. This is when your calculator comes in. You go log 16 divided by log 3, and I'm going to put some little squiggly equal signs because we're going to estimate this to 3 decimal places and round correctly. This would be 2.524. Round to 3 places. Alright, number 9 is the same type of problem, except we still want to get the e, or not the e, but we want to get the x by itself. So let's work on getting this part by itself. Let's get rid of the 5 first. So the first step is to subtract 5. So negative 3 e to the x equals, subtract 5 from 2 and you get negative 3. Then we need to divide by negative 3. So you get e to the x equals positive 1. Now hopefully I don't have to go a whole lot further here. Hopefully you can look at this and recognize, look at that. I'm giving you a second to absorb it. Look at it. Soak in. What exponent must that be? What exponent always gives you an answer of 1? Anything to what power equals 1? X has to be 0. Anything to the 0 power is 1. Hopefully you see that. If you don't see that, hopefully you see that. If you don't, left, right, left. Log base e of 1 equals x. Remember, a log base e is ln. Do ln of 1 equals x. Pen's going nuts again, sorry. ln of 1, type that in your calculator and you'll get 0. Okay, but y'all got to start recognizing where anything to the 0 power is 1. Number 10 is another problem similar to what we just did. First step here would be to subtract. Subtract 4, so I have 6 times 2 to the t plus 5 equals, subtract 4 from 11 and you get 7. Then I need to divide. So I have 2 to the t plus 5 equals, now if I divide 6 by 7, it does not divide evenly and it does not turn out to be a nice decimal, so do not round. Do not round until the end. I'm put on here, don't round until the end. Okay, if you round now and put a decimal there, you will mess up. You will not get the right answer. So don't round until the end. Okay, from here, that's about as far as we can go with this form, so we need to change to logs. change to logs. Split that up a little bit. Change to logs. Left, right, left. Log base 2 of 7/6 equals t plus 5. Okay, we need to calculate change of base. So I need to calculate this right here with change of base. And then after I calculate this, then what do I need to do to get rid of this plus 5? Then subtract 5. Okay, so here's what I would do in my calculator. I would have to type in log of 7/6 divided by log of 2. And once I get that answer, then I will subtract 5. And that will be approximately negative 4.778. Number 11 is what we call a quadratic type because we need to factor on this one. And it's not going to be any harder to factor than just a normal simple factoring problem. So when you look at e to the 2x, you need to think about what's going to multiply to give me e to the 2x. Well, that's going to be e to the x times e to the x. Think about it. E to the x times e to the x is going to be e to the, add your exponents, x plus x is 2x. So that's where that comes from. Positive or plus sign here, negative there means they're both negatives. And that would be 3 and 4 to multiply to get 12 and add to get 7. So now we factored this and we just have two equations that we need to solve now. So I am going to have e to the x minus 3 equals 0 and e to the x minus 4 equals 0, and I need to go through here and solve both of these. So e to the x equals 3 and e to the x equals 4. From here I am going to have to turn this into logs, so I'm going to go left, right, left. Log base e of 3 equals x and log base e of 4 equals x. And we know that log base e means natural log. So that's natural log of 3 equals x and natural log of 4 equals x. So now all we need to do is type in our calculator, natural log of 3 and natural log of 4, and I'm going to come over here so I have some more room. Natural log of 3 is approximately, and then natural log of 4 is approximately, and we're going to round to 3 decimal places. 1.386 is natural log of 3 and natural log of 4 is 1.099. So there are my two answers for number 11. And we have one more in this section. Natural log of x equals 2/3. Natural log or ln again is log base e of x equals 2/3. Left, right, left. E to the 2/3 equals x. 2/3 is an exponent. Just calculate that in your calculator. E, there's an E button on your calculator. E to the 2/3 exponent. So x is approximately 1.948. 13 and 14 give us a little more practice with the one-to-one property. On number 13, we have log base 4 once on the left and log base 4 once on the right. In other words, everything is condensed. There's nothing to condense here. So I can eliminate the logs, and I'm going to solve 3x plus 2 equals 6 minus x. Simple algebra equation. Just solve it. So 4x equals 4 and x equals 1. This is the one-to-one property. So when we get to number 14, what some of you are going to be tempted to do, and this is, I'm going to put a little star here, I'm going to put careful, because I'm going to show you what a lot of you are going to be tempted to do. And I'm going to show this in red, and then I'm going to erase it. Here's what a lot of you are going to do. You're going to say log 3. Ooh, mark out all the log 3's. And you're going to try to write down what you have left. Wrong. Do not do that. You have to condense first. You have to condense first. Okay, so I'm going to take all that off. And I'm even write in red that we have to condense first. Okay, condense first. So over here on the left, I need to condense this so that I have log base 3 one time. So if I condense this, this is a minus sign, and if I condense, then I'm going to have 5x plus 13. A minus sign turns into division. And then on the right hand side, I didn't have anything condensed because I had log base 3 one time. So now that I am condensed, now I can break out the one-to-one property. Now I can eliminate my logs. I can write down what I have left. And now I can solve this. This is just a simple proportion from here. If you want to put this over 1 and just cross multiply from there, it's just a simple proportion. So 18x equals 5x plus 13. 13x equals 13. Don't think they all turn out to be 1, because they don't. It was just a coincidence that those both turned out to be 1. Condense first. I can't stress that enough. I promise you, a lot of you will not condense first, and y'all will mess up on those. Be careful. Alright, we're going to finish up here with a couple more solving equations before we get to our last two examples. Alright, the first step here, remember our goal again is to get the x by itself, so I need to get rid of the 6 by subtracting. I'm just going to abbreviate here, subtract 6. So 3 natural log of x equals, subtract 6 from 4, and you're going to get negative 2. And then divide by 3. So natural log of x equals negative 2/3. Put divide. Natural log is log base e of x equals negative 2/3. Let's turn it into exponents. Change to exponents. Left, right, left. E to the negative 2/3. It's a 2. Negative 2/3 equals x. Calculate that in your calculator. E to the negative 2/3 is approximately, not negative, sorry, 0.513. 3 decimal places. And the last solving one here, number 16. The first thing we should do is get rid of this 3 by dividing. So I'm going to put divide. Log base 4 of 6x equals divide by 3 over here, and you're going to get 3. So now let's change to exponents. Left, right, left. 4 to the 3rd equals 6x. 4 to the 3rd power is 64. 64 divided by 6, and reduce that, would be 32/3. If you can possibly give a nice fraction, don't always type it in the calculator and give an ugly decimal. That's a nice fraction, so leave it as a nice fraction. One thing you need to be careful of when working with logarithms is when extraneous solutions pop up. Sometimes you'll get some extra answers that aren't really answers, so you need to watch out for that, and I'll show you what happens on this problem. Number 17, the first thing you need to do is condense. So on the left hand side, let's condense this. So I have log base 10 one time, log base 10 of x. This is a plus sign, so this is x times x minus 9 equals 1. Log base 10 of x squared minus 9 equals 1. 9x. Sorry about that. Let's take it out of logs and let's turn it into exponents. So left, all this to the right and this to the left. 10 to the first power equals x squared minus 9x. Let's move everything to one side, set everything equal to 0. 0 equals x squared minus 9x minus 10. Let's solve, factor and solve. X minus 10 times x plus 1. Alright, set all these equal to 0, or set both of these equal to 0. And I will get positive 10 and negative 1. Now if you're not careful, you'll circle these and say those are both my answers, and you'll go on and you'll miss part of these because only one of these are your answers. Only 10 works. Only this one. We have to mark out the negative 1, and I'll show you why. We need to check. Okay, only 10 works. You can't take the log of a negative. If you have a calculator handy, I would like for you to try typing in log of negative 1, and it won't work. You get a non-real answer. I mean, think about if we were trying to do this. Log base 10 of negative 1 equals something. So you'd be trying to tell me that 10 to some exponent is going to equal negative 1. Can you take positive 10 to any exponent and come up with a negative number? That's not going to happen. Your log bases are positive numbers, and you're never going to get a negative answer out of that. So that's why you cannot take the log of a negative number. So if you're ever working something like this and you come up with a negative answer, you're going to toss that out and you will only keep the positive. Okay? Only keep the positive answer. Only keep the positive answer for extraneous solutions. Alright, we made it to the last example. You have deposited $1,000 in an account that pays 6.25% interest compounded continuously. Here's our formula. A equals P-E to the R-T, PERT. How long will it take your money to double? How long will it take your money to double? So if you put $1,000 in the bank, if we're going to double it, that means we want to have $2,000 in the bank. So if we want our money to double, the amount of money we want to have in the bank will be $2,000. My principal, or what I started with, was $1,000. E is always just E. Now R is my rate. 6.25% is 0.0625 as a decimal. So that's 0.0625 as a decimal. And then T is time, and that's what we're looking for. We're looking for how long, and that means we are looking for time. So we are going to figure out how long it takes to double. The first thing I would do is work on getting this part by itself. I would work on getting this part by itself. So the first thing I would do is divide by 1,000. And if you divide by 1,000, then miraculously you end up with a 2 right there. Now think about this. If you're going to double, isn't doubling the number 2? That's why you ended up with a 2 there. If you're going to triple, you'd end up with a 3. If you'd quadruple, you'd end up with a 4. And that's just the way it works. So double, we ended up with a 2. So 2 equals e to the 0.0625t. Now I'm going to flip this around. E to the 0.0625t equals 2. So that I can go left, right, left, and turn this into logs. Log base e of 2 equals 0.0625t. Log base e means natural log of 2 equals 0.0625t. You can calculate the natural log of 2 and then we'll divide it by 0.0625. So calculate that and then you'll find out how long it'll take. So natural log of 2 divided by 0.0625 will give you the number of years, and it's approximately 11.1 years is how long it would take your money to double at that interest rate. And that completes section 3.4.